Good day. You've been introduced to oxidation numbers. This PowerPoint's going to have a lot of information. It may overwhelm you a bit. Don't panic. It's stuff we'll build on in the coming days, but it's also something you can revisit if you're getting a little confused. You look at this and you see redox. It's not redox, it's redox. Red for reduction, ox for oxidation. And it turns out in chemical reactions that are redox reactions, it means you have electrons being transferred from one chemical to another. And we're going to go through what that means. So if you have reduction, that means a reduction in the charge. And the way something has its charge reduced is by gaining electrons. You gain electrons, you gain a negative, it drops down your charge. We go to opposite land, oxidation has to be the loss of electrons. So, if that's the case, the charge has to go up. And in fact, when things chemically combine with oxygen, their charge went up, and that's why it's based on the word oxygen, oxidation. So when we have a redox reaction, these things are happening at the same time. Something's being reduced at the same time something's being oxidized because electrons are going from one chemical to another. So we have something called a reducing agent. And a reducing agent is something that causes something else to be reduced, and therefore it itself is oxidized. So if it's a reducing agent, it means it's given up electrons to the other thing. And if we have, I must have the wrong order, here we go. If we have an oxidizing agent, an OA, therefore it oxidizes the other chemical, and that means it itself is reduced. It's gaining electrons to do that. Oxidation numbers you were introduced last day to, or in a previous PowerPoint, and so hopefully that stuff is making sense. So now we're going to look at an example. Here is a reaction that's been boiled down to a net ionic equation, and by inspection we see we had copper at 2+, and the copper became an element. So it went from ion to element, and you can see its charge went down. So the copper 2+ was reduced. Automatically, that means the aluminum has to have been oxidized, and it was. It went from 0 to +3. So if this was reduced, that means it is an oxidizing agent. And if this is oxidized, then this is a reducing agent. You're looking at what they do to the other chemical. And we're really looking at the left-hand side of the equation for oxidizing and reducing agents. So here we had the main equation. We boiled it down to our net ion equation because these things are coming in a funky order. And we can now split this into two half reactions, and they come in a weird order. So we can say, okay, well here's the aluminum being oxidized, and here's the copper being reduced. The aluminum became Al3+ and generated 3 electrons. The copper picked up 2 electrons and became Cu. And it turns out when we go to balance equations, we really have to balance the electrons. Once we balance the electrons, we're going to have no problem balancing a redox equation. So like I say, I've thrown in lots of terms at you. Oxidation, reduction, oxidizing agent, reducing agent. Oxidation is always where the charge or oxidation number goes up, and reduction is always where the charge or oxidation number goes down. Oxidizing agents oxidize something else and reduce themselves. Reducing agents reduce something else and therefore oxidize themselves. So hopefully that is making some sense, but you can always revisit this if it gets a little confuddling. And there's our last reminder, Cu2+, the oxidizing agent, and Al reducing agent.